Hey guys, so chain rule homework, it's definitely a tougher one to get the concept of, but we'll be doing enough of the chain rule, I think, that hopefully um, you're feeling more comfortable with it. Here are some of the questions I've gotten today. If you have more than just this, see if this clears it up first. Some additional instruction. As you guys know, I do a lot of my teaching the second day when you're asking homework questions. It kind of helps us work out those kinks and misunderstandings. So that is quality time that you don't get off of my instructional just plain videos that are online. So don't hesitate to ask. So on this one, number 27, I'm thinking quotient rule. I would rewrite the bottom in this fashion though, just so I can visualize the chain rule down here, because I know this is going to be a chain rule because it's not just an x raised to a 1/2 power. It's a function, really, a separate function raised to the 1/2 power. A separate function that's not just plain x or just a plain linear. So I'm going to start with the bottom, which I can leave like that for now. Bottom times the derivative of the top, which is 1. So times 1. I'm going to choose not to write that. Minus the top times the derivative of the bottom. Now the derivative of the bottom here is where the chain rule is going to come in. I'm going to bring the 1/2 out in front, times do not touch, and reduce this by 1, times the derivative of what's inside. And the derivative of what's inside is this piece. So the derivative of that is just 2x. So when I'm cleaning this up, I've got x squared, all over bottom squared, right? Bottom times derivative of the top minus top times derivative of the bottom, all over bottom squared. So I'm going to do bottom squared is just x squared plus 1. The square root of something squared is just x squared plus 1. Let me just differentiate this with a little more space. So now up top I've got some cleanup to do. X squared plus 1. The 1/2 times the 2 cancels. And then I have x squared. Technically, because of this negative exponent, it's got to move to the denominator and would be like root x squared plus 1 all over this x squared plus 1. So this second portion really just became a complex fraction, which you haven't heard me say in a while, but we've got to clear the fraction. So I'm going to multiply the top by root x squared plus 1 and the bottom by root x squared plus 1. Now in the top, when I distribute it there, I'm going to get just plain old x squared plus 1. And to the second one, it's actually going to clear that fraction. So minus x squared over, and then in the bottom, I'm just going to keep it as this times this. Don't really need that second set of parentheses, but it makes it cleaner. Then x squared minus x squared is a wash, and I would be comfortable with this, although I'll check the back of the book and see if they went further with it and rationalized. I'm going to say I doubt it, but perhaps.